In part 1, I showed you how you can graph an exponential function by using the 3 points that are always on the graph of an exponential function. Another method for graphing exponential functions is to evaluate the function for several x values in its domain. Once you plot those points, you can then sketch a smooth curve through each ordered pair. Here are some x values we're going to plug in. Let's start with -1. So we're going to remove the x from the original equation and replace it with -1. When we do so, it's going to look like so. Remember, anytime you have a negative exponent, to make it positive, you have to flip it or write the reciprocal of it. And what that's going to give us is an output of 1/5. Now let's plug in a 0 for x. Remove the x, replace it with a 0. You should know that any number to the 0 power equals 1. So 1 is our output. Next, we're going to plug in a 1 in x's place, and we get an output of 5. Lastly, we're going to plug in a 2. Once we plug in a 2, we have 5 squared, which is 25. And now that we have 4 ordered pairs, we're going to go ahead and plot these ordered pairs on the rectangular coordinate system so that we can sketch our graph. So after plotting the points and drawing a smooth curve through them, this is what our graph looks like. Now let's find the domain and range of this graph. Let's start with domain. Domain, how far does this graph extend to the left and to the right? So if we look to the left, we have an arrow there. And to the right side, we also have an arrow. And you should know that arrows go to infinity. And so since you have it in both directions, our domain is going to be from -infinity to +infinity. Range, how high, how low does our graph go? Well, as we can see here, our graph does not go any lower than 0. Now it does not include 0. It gets really close there, a fraction of there, but it never touches 0 because it has that asymptote at y = 0. And recall, it's not going to cross that asymptote. So we would say from 0, and we put a parenthesis around 0 to mean that it does not include 0. But then it's going to shoot forever up to +infinity. So the range is from 0 to +infinity.